Today we're going to be talking about problem solving and finding missing numbers in the mean problems or the average problems. So the easiest way that I can explain this to you and show you this is to imagine that you have a brother and a sister, and your mom comes home and she gives you $3. And she gives your brother $5. And she gives your sister $7. It doesn't take much for you to understand that this is not really equitable. It's not really fair. Now, it might be representative of what you deserve. Maybe your sister did more chores. But let's imagine that you wanted to figure out how much each of you should have gotten if you would have distributed it evenly or equally. The easiest way to do that is to put all of that money back into one large pot. So it looks like this. And then mom could give you $1, your brother $1, and your sister $1. So really we're just dividing. You $1, your brother $1, your sister $1. So mom would continue to do this until she didn't have any money left over. And then we would see that each person would end up with $5. And so it's equally distributed across the siblings. So today what we're going to be working on, if you'll remember that we're trying to equally distribute, and remember that whenever we first looked at average or mean, we said it was kind of like the balance point of our data set. Today we're going to be looking at problem solving with missing values. So again, the mean or the average means that you group all of the data into one large group and then distribute it out evenly into smaller groups. That's exactly the model that we just looked at. Today we're going to talk about two strategies to help you find missing data in a mean or an average problem. The first is we're going to think about like a balance beam or a seesaw or a balance in a science class, if that's what you want to think about. And we want our parts to be evenly distributed, sort of like the dollars that your mom gave you and your siblings. So this is the first example that we're going to do. It says Marley had the following scores on her math tests for the second grading period. We know that she's already taken 4 tests. She made an 83, a 95, a 92, and an 87. Now Marley's parents are pretty hard on her, and they tell her she has to have an A. So Marley has to have a final average of 90. This is her goal average. So we want to know, what does her final test score need to be to accomplish this? Now some students might just start trial and error. They might just try to guess a test score. Like they might say, oh, I think she has to make an 80, and they would try to determine her average. And that's doable, but that's also going to take you a long amount of time. So an easier way to do this is to use what we call the balance method. So to do this, we are going to draw a line, and we're going to make a balance. Now, in that balance, we're going to talk about what Marley's goal score is. So her goal is to have a 90. That would be the balance point for our seesaw or our balance. Now I'm going to take the test scores that she's already made, and I'm going to see if I can put them on this balance. Now, 83 is less than 90, so I'm going to write it right here. 95 is more than that balance point, so I'm going to write it up here. 92 is also more, but it's less than 95, so I'm going to put it here. And 87 is less than 90, but more than 83, so I'm going to put it right here. Now we want to see if we can make these balance. So here's how that works. This 92 is more than her average is supposed to be. So I want to make this say the average of 90. So I can do that by taking 2 away from that so that this one now says 90. This one is 5 over the average of 90. So I can take 5 away from that one so that this one now says 90. So basically I'm trying to make them all say the same. We're trying to distribute that money kind of like your mom did with that example at the beginning. Now on the other end, these are not quite up to 90. So what I'm going to do is I'm going to take some of these numbers that I took from here and I'm going to add them to this. So I'm going to take these two and I'm going to add 2, and that makes that an 89. I'm going to take this 5 and I'm going to add 1 to that one to make it a 90. So now this one balances with these. I've used this one and I've used 1 of this one. So I have 4 left. So I'm going to add those other 4 right here, and that makes this an 87. Now my end goal is an 87. So how far is 87 away from 90? Well, I would have to add 3 to that to make it say 90. So that tells me her target score is 90 plus the extra 3 points that she needs to make that one say 90 would mean her final score has to be a 93 on that test. To check it, what we're going to do is we're going to see if that works. So her test scores were 83, 95, 92, 87, and then we determined that her final test score was a 93. And when we divide that by the 5 tests that she's taken, you see that her final average is a 90. So let's do another example. This one says, Allie practiced piano 5 days last week. She remembers that she practiced 35 minutes on Monday, 40 minutes Tuesday, 30 minutes Wednesday, and 25 minutes Thursday. She cannot remember how many minutes she practiced on Friday, but she does know that her average practice time was 35 minutes. So your job is to determine how many minutes did she practice on Friday. So we know that she practiced 40, 30, 25, and 35. And that her average, or that hinge score, was an average of 35 minutes. Right there, it tells me her average practice time was 35 minutes. So these are the 4 numbers that I do know. I'm trying to determine that last number. So we're going to put these in. 40 is greater than 35, so I'm going to put it here. 25 is less, 30 is less, and 35 I'm going to put right here because it is exact. So now my job is to see if I can manipulate any of these to make them reach that target number of 35. It's pretty quick once you realize it because I can do -5 here, and that makes that one say 35. And if you are number oriented, you see I can take those 5 that I took from there and I can add it here, and that makes that one say 35. So here's my final score that I was not able to manipulate. I want to make it say 35, so the way to do that is to add 10 to it. So her final practice time is the original 35, the target score, plus the extra 10 minutes that she needs to practice. So that means she's going to need to practice for 45 minutes on that Friday to average it out. Let's check it. So 35 minutes on Monday, 40 minutes on Tuesday, 30 minutes on Wednesday, 25 minutes on Thursday, and we determined that she had to have practiced 45 minutes on Friday. And then we're going to divide that by our 5 days. And as you see, that was the 35-minute average that she came up with. Okay, so that is what we call the balance method. The other method is what we call working backwards, which is really algebraic thinking. You don't really realize it, but that's what you're doing. So typically, whenever we find the average, we add our numbers up and then we divide it by the number of data points that we have. So if we want to work backwards, then we're going to multiply and then subtract. So let me see if I can explain this to you with an example. It says Austin's coach told him he had an average of 3 hits per game during his last baseball season. He played in 8 games. Okay, so that is important to us. He played in 8 games. His father told him he hit 2-3-0-5-6-2 and 2 hits, but he couldn't remember how many hits he had in the first game of this season. How many hits did he have for his first game? So we know that he played in 8 games. So we know that whenever we add all of our numbers up, we were going to have to divide it by 8 to get to his batting average. So instead of doing that, we're going to kind of work backwards. There were 8 games, and he has an average of 3 hits per game. So we're going to work backwards. We're going to take the average of 3, and we're going to multiply it by 8, and that tells me that my sum has to equal 24. Now, we don't know what his first game was, but we do know that the other games were 2, 3, 0, 5, 6, 2, and 2. And because we know that our sum has to be equal to 24, we're going to put 24 over here. Now, if you are math-minded at all, then this is not going to be hard, because all you have to do is figure out what is the missing number that would have to go here that would make all of this equal 24. So the easiest way that I can do this is I can add up the numbers that are here. So 2 plus 3 is 5, and a 0 would just be 5, plus 5 more is 10, plus 6 is 16, 18, and 20. So just this part right here is 20. So some number plus 20 is equal to 24. Well, it doesn't take you much time to realize what's the number that has to go here. If you can't figure out how to solve that, you can just do minus 20, and we see that our answer is 4. So in that first game, he had to have had 4 hits. Let's go in and check it. Okay, so that means 4 hits in the first game, then 2, 3, 0, 5, 6, 2, and 2. And that's 8 games total, so divide that by 8 means his batting average was 3 hits per game. Let's do one more example. It says the average number of students who ate breakfast last week was 86 students. On Monday, there were 74 students who ate breakfast. On Tuesday, 92. On Wednesday, 83. And on Thursday, 98. We do not know Friday's number of students because the cafeteria staff forgot to write it down. However, they do know that when they add all these numbers up and they get a sum, they're going to divide it by 5 days. And our answer is going to be 86 for an average or for a mean. So we're going to kind of work backwards. We're going to start here, and we're going to do 86 times 5. So 86 times 5 would give me 430. So the sum has to be 430. So 74 plus 92 plus 83 plus 98 plus whatever the number was on Friday has to give me 430. So we're going to figure out what this has to be. So we're going to do 74 plus 92 plus 83 plus 98. All of those together are 347. Now, there's a mystery number here, and when I add it to that, it gives me 430. So if I don't know how to do this, let's see if we can figure this out. Let's get rid of that 347. So 430 minus the 347 means the missing number had to be 83. So on Friday, 83 students had to have eaten breakfast in order for the average to end up being at an 86. Let's go back and check that just to make sure. So we're going to do 74, 92, 83, 98, and the 83 students that we determined. We're going to divide that by the 5 days, and you see that that is an average of 86 students. I hope this video has been helpful in you figuring out how to problem solve with problem solving with missing values.